Everyone, when you're completely clueless about how to solve a problem, you must remember the universal K method. The universal K method can solve 99% of problems like this, such as finding the maximum or minimum value. Let's take a look. Given that x squared plus x times y plus y squared equals 15, find the maximum value of x plus y. Of course, there are many ways to solve this kind of problem, but how do we use the universal K method? First, let's make an assumption. Assume that the maximum value of x plus y is k. Let's suppose its maximum value is k. In that case, let's swap x and y. You don't have to swap both. You can just swap x or y. Let's swap y. What does y equal? Isn't y equal to k minus x? Everyone, isn't y equal to k minus x? Then substitute this k minus x everywhere. Replace all y with k minus x. And see what it becomes. Everyone, x squared plus x times y, right? X plus x times y. Y is what? Isn't it k minus x? Everyone, is there any problem with that? Then add y squared. Y squared, isn't that open parenthesis k minus x close parenthesis squared, right? You have to be careful when solving problems. Then it equals 15, right? The original equation now looks like this after replacing all y with k minus x. Is there any problem with that? No problem, right? Be careful when doing problems. Now let's expand it. X squared plus how much? X times k, that's kx, right? Everyone? And this part, isn't it minus x squared? And this part, if you expand this, it becomes k squared plus x squared minus twice their product, which is 2kx, right? Any problems with that? Move the 15 over. So minus 15 equals 0, right? Be careful when solving problems. Now, doesn't the equation look like this? Let's combine like terms. Let's combine them. This x squared and this negative x squared cancel each other out, right, everyone? Then isn't there only one x squared left? Just x squared, right? Look at the linear terms, This kx and this negative 2kx. What do they become? They become negative kx, right? Is there any problem? Are you ready to submit for verification? No problem, right? What about the constant terms? Isn't it k squared minus 15? Everyone, is there any issue? This is the constant term, right? This is the constant term. Make sure not to miss it. Then it equals 0, right? So the original expression becomes like this, doesn't it? And then everyone, isn't this a quadratic equation in one variable? It's a quadratic equation in x. Everyone, k is a constant term. What should we do at this step? For this equation to have real solutions, it must satisfy a certain condition. What is that condition? Isn't the discriminant supposed to be greater than or equal to 0? Everyone, what is its discriminant? Isn't it b squared minus 4ac? Isn't this b? So b squared is k squared, right? Minus 4 times. What is AC? Isn't AC just k squared? Minus 15, right? The constant term is k squared minus 15. So the discriminant is k squared minus 4 times. K squared minus 15. And it needs to be greater than or equal to 0, right? The value of delta has to be greater than or equal to 0. Now let's calculate what k equals. K squared minus 4. K squared is negative 3k squared, right? Any questions? Then minus 4 times 15, doesn't that become plus 60? Right? It's plus 60. Be careful when doing problems, okay? 4 times 15 is 60, so it's greater than or equal to 0. What does it mean for it to be greater than or equal to 0? Move the 3k squared to the other side. So isn't it 3k squared less than or equal to 60? Divide both sides by 3 and you get k squared less than or equal to 20, right? So what does that make k? If k squared is less than or equal to 20, then k is less than or equal to the square root of 20, right? What's the square root of 20? Isn't the square root of 20 equal to 2 times the square root of 5? And it also has to be greater than or equal to negative 2 times the square root of 5, right? K squared is less than or equal to 20.